Hello, algebra students. Mr. Lawrence here, and we're going to be factoring trinomials again. Well, in some cases they'll be binomials, but like number 2, but factoring trinomials nonetheless. All right, so remember, to do the first problem here, we have to multiply A times C, right? So we're going to do 120. Notice I'm ignoring the sign. And so I'm going to list the factors of 120. Now look, I know you're pretty smart. When I get the factors of 120, I'm going to subtract them to get negative 7. So it's probably not going to be the ones on the down the end, like 1 times 120 or 2 times 60. I might list some, because it, I don't want to miss anything, but I know it's going to be somewhere close to the middle. And I know the square root of 121 is 11, so the square root of 120 is going to be around 11. It's going to be maybe 3 or 4 away from 11. I'll bet you it's going to be like 8 or something. But let's see. So let's see, 4 and 30. Okay. 5 and 24. If I subtract those, I only get 19. Negative 19, that's not what I want. 6 and 20, that's 14 away from each other. 7, I don't believe 7 goes into 120 evenly. Let me check really quick. 7 into 12 once, 15. No, it's not going to go in. 8 is going to go in 15 times. And look at that. You get 7, don't you? See how I kind of reasoned it out? You can use your number sense to help you figure out where you're going to be about. Now, could I have gone right there? Sure, I could have. But some of you don't have that level of number sense yet. So I chose not to. Now the subtraction problem would be 8 minus 15 because I need a negative 7. So I think I'm going to write a 6x squared. I'm going to rewrite the negative 7 as a positive 8x minus a 15x minus a 20, and I like the way that's looking. So I'm going to GCF this quantity, which I believe is going to be a 2x, and I'll be left with a 3x plus a 4. And I'm going to GCF this quantity, which will be a minus 5, and I'll have a 3x plus a 4. And so I'll GCF one more time. I'll have 3x plus 4 times the quantity of 2x minus 5. Piece of cake. All right, number 2, I've got to find the product of 64 and 9. There's actually a way easier way to do this one, and I'll talk about it in a minute. All right, so let me do 64 times 9. All right, so that's going to be 6, carry the 3, 54, 576. Whoa, I don't really know too many factors of 576. But you know what? 576 is a perfect square. Yeah, I think it's 24. Let's check that. See, if you know your perfect squares, up through 25, math becomes a little bit easier. 24 squared, yep, 576. Okay, so I need 2 factors of 576 that subtract to get 0, because there's no x term there, right? 64x squared plus 0x minus 9, right? I want a 0 in the middle. So it's going to be the square root of 576, or 24. So I'm going to do this a long way. 64x squared plus 24x minus 24x minus 9. And then I'm going to group, right? Grab that negative sign, and let me see here. I think 8's going to go into both. I don't think there's a bigger number, 8x, and that'll get me what? 8x plus 3. And I'm going to pull out a negative 3, I believe, and I'm going to get an 8x plus 3, and then I'm going to pull out the 8x plus 3, leaving an 8x minus 3. Now you see the pattern, how that came out? This one could have been like 1,000 times easier. Okay, this pattern, well actually, this pattern here is called the difference of perfect squares. Now, I won't require you to use it doing the difference of perfect squares, but if you know your perfect squares, this is pretty easy. Let me show you how to do this. Okay, first of all, is this number a perfect square? Yep, 9, square root of 9 is plus or minus 3, right? Okay, we're going to deal with the positive square root in most cases. And here, is this number a perfect square? It sure is. The square root would be 8x. So, see I have an 8x and a 3. The difference of perfect squares, oh, you got to make sure this is subtraction. Must be subtraction. If you have two positives, you cannot do this trick. It will not work. If you had 4x squared plus 25, this is actually prime. This trick will not work unless there is one subtraction sign. Okay? It could be a negative 9x squared plus 64 because there's the one negative, but there must be one negative for this to be the difference of perfect squares. All I do is write 8x, 3, 8x, 3, and then I take one positive, one negative. I can factor it that quick. In fact, I'll make up another problem here real quick. How about if I had 36x squared minus 121? Okay. They're both perfect squares, right? Square root of this is 11. Square root of that would be 6x. There's a negative. This will factor as 6x plus 11 and 6x minus 11. I don't know about you, but I'd rather do that instead of multiplying 36 by 121 and then trying to find factors. Okay, now of course you're allowed to use a calculator to help you, but if you recognize the difference of perfect squares, it becomes so much simpler. All right, here's two more trinomials, just like problem number 1. I'd love for you to pause the video at this point and try to factor them on your own. Okay, if you're still watching, here comes my solutions. All right, so first of all, I'm going to do 9 times 4, and I'm going to get 36. And I'm going to list the factors of 36. Now I need to add them to get negative 12. They're going to be pretty far apart from each other, aren't they? All right, so let's see, 2 and 18. Oh, that's almost, no, that's 20, not 12. Hey, wait a minute. 6 and 6 is 12. Yeah, I didn't need to list all the factors because I recognize 6 and 6. So I need negative 12. That means they're both going to be negative, right? Because I'm adding. So I'm going to rewrite this as 9x squared minus 6x plus 4. And I will factor out a 3x. And I'll have 3x minus 2. And here I'll factor out a negative 2, I believe. And I'll get a 3x minus 2. And then I'll factor out the 3x minus 2. What will be left? A 3x minus 2. This one is actually a different pattern called a perfect square trinomial. Yeah, it's a perfect square trinomial. If you know this pattern, man, factoring can be way easier. Watch how quickly I can do this. All right, so this is a perfect square, right? Square root would be 3x. This is a perfect square, 2. If I multiply them together, I get 6x. And if I double it, I get 12x. So all I do is go 3x, 2, 3x, 2. When there's a plus in the back, it's the Wendy's double stack. Boom, boom. They both have to be negative. How did I do that so quick? Well, check it out. If I have a perfect square in A's position, and I have a positive perfect square in C's position, if the middle number is twice the product of the square roots. So for example, the square root of this is 4. Square root of this would be 5x. If I multiply them together, I get 20x, right? Times 2 is 40x. If that's the case, I take this square root, 5x. He leads both quantities. I take this square root, 4. It closes both quantities. Plus in the back is a Wendy's double stack. They're both positive. Boom, boom. Perfect square trinomial. Pretty easy stuff. Okay, now, number 4 is not a perfect square trinomial because 6 isn't a perfect square, 5 isn't a perfect square. So I'm going to multiply by 30. Now, by the way, you can still do it the way I did. I mean, I did it without using the perfect square trinomial fact, but if you recognize it, it can make your life a little easier. 1 and 30, and before I list all the factors, I'm going to stop and think I need to subtract the two factors to get positive 29. Wouldn't that be 30 minus 1? Why should I list any other factors? I'm going to write 6x squared plus 30x minus x minus 5. So I'm going to do a little group in, do a little group in, do a little group in, do a little group in. All right, GCF there I think is 6x and that'll leave me with an x plus 5. And GCF here will be a negative 1, leaving me with an x plus 5. I'll factor out the quantity of x plus 5 and have the quantity 6x minus 1. And there you go. All right, here's the video quiz. 2 problems. Hey, this one looks kind of like problem number 2 in the video. Maybe you want to go back and rewatch it. And this one looks like number 1 or number 4 that I did. All right, Mr. Laurence signing off. Have a good night, everybody. I can't find my stop button.